Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's video, we will do practice problems on Kirchhoff's laws. This video will help you to understand Kirchhoff's laws in depth, and also it will give you confidence to handle Kirchhoff's problems in future. Let's try to answer this question now. For this question, we need to understand Kirchhoff's first law. The first thing we need to understand Kirchhoff's first law. And if we have understanding of Kirchhoff's first law, then we can find the current in the 4 ohms resistor and in 8 ohms resistor. Now, so first of all, the circuit is given to us, so we need to understand how to use Kirchhoff's first law and what is Kirchhoff's first law. Kirchhoff's first law is simply at any junction. So Kirchhoff's first law is simply at any junction. At any junction. Junction simply means, let's say this is a point is a junction, and here, so we can call this point as a junction, and it is also called node. So junction and node are the same. Junction. Okay, so at any junction, I entering has to be equal to I leaving. I entering has to be equal to I leaving. So this is Kirchhoff's first law, and this law is also called KCL. Now, how we can apply this rule here or the law, and we can find current passing through 4 ohms resistor and 8 ohms resistor. So the first thing we need to understand, as 4 and 8 ohms resistor, they are connected in series. It means current has to be the same. So I can also say I4 has to be equal to I8. Now, how much current is entering? That is 1.75. So we can write down how much current is entering. That is 1.75 amps. Now, how much current is leaving? That is 1 amps. And this side also there is current. So we have 1.00 amps plus also some current is leaving. And then if we solve for that one, for the missing current, that will be 0.75 amps. And so it simply means I4, I8 are equal to 0.75 amps. So this is our answer for part 1. So this is how simply we can answer. Now let's move on to next one. So the next part is asking us, we need to calculate EMF of E1, means EMF of battery number 1. So how we can calculate EMF of battery number 1? So in order to find E1, we need to understand Kirchhoff's second law. Kirchhoff's second law is also called KVL. According to KVL, in any loop, delta V has to be equal to 0. So before we apply this rule, we need to understand some basic conventions for battery and also for other consumers of electricity, or simply we can call them resistors. For example, for battery we can simply use very simple convention. So that convention is, let's say this is our battery, and if we go from positive terminal, this terminal is positive, this small one is negative. If we go from positive terminal to negative terminal, voltage will drop, or we can say V will be minus, our EMF is minus. On other hand, if we go from negative terminal to the positive terminal, we will gain voltage. So V has to be positive. V has to be positive. Now for resistor, we need to understand if we go in direction of current, let's say I current is flowing in this direction, means from left to the right. So in this case, V has to be negative. On other hand, if we cross in opposite direction to the current, so the V has to be positive. So this is very important, very simple concept, but we have to be very clear about this one to answer this question and to use Kirchhoff's second law. Let's try to answer this question now. So let's say we start from this point, and if we cross this battery, we are moving from negative terminal to the positive terminal, so we will simply say E1 has to be positive. Now if we go in direction of current like this, so let's say this is overflow. So if we go in direction of current, as we have already found, current in 4 passing through 4 ohm resistor is equal to 0.5 amps, 0.75 amps. So it has to be negative. So we can write down the voltage that will be equal to I times R. So means the V is equal to I times R. So we can say that is 0.75 multiplied by 4. And the same is true for 8 ohms resistor. So the voltage also has to be negative. So again, we can write down that is 0.75. 0.75. So just let me make some space. Okay, 0.75, and resistance is 8. So this is a one loop, so delta V has to be 0. Now if we solve this one, so E1 we can also write down is 0.75 and multiply by 12, means 8 plus 4 has to be 0. And if we solve for E1, we will get that is equal to 9 volts. So this is EMF of battery number 1. So this is how we can find the EMF. This is. So that's all for part 1 and part 2. For this question, we need to find E2. We need to find E2. Means the EMF of this battery. So how we can find out? So to find EMF of this battery, again, we need to use KVL. In KVL, we simply understand in any loop according to KVL, delta V has to be equal to 0. Now, so we need to choose a loop. So let's say we consider this loop. This loop. Now if I start from this point, I go from negative terminal to the positive terminal, so EMF will be positive. So voltage is positive, mean voltage gain, so we can say plus E1. And when we cross from positive terminal to negative terminal, so voltage will drop, so we can say E2 is minus. And again, when we go in direction of current, as the I through 3 ohm resistor, that is equal to 1.0 amps. So the voltage across this voltage will drop when we cross this resistor. So is minus, so current is 1.0 amps, and the resistance of this resistor is equal to 3 ohms, and it has to be equal to 0. In any loop, means there is no resistance, so it has to be equal to 0. E1, so we need to find E2. We can also write down E1 minus 3 has to be equal to E2. Now we understand E1 we have already found in previous part. E1 was equal to 9 volts. So 9 volts. So we simply need to plug in value of E1 and we will get value of E2. So E2 will be are equal to 6 volts. So this is how we can answer this question. Okay, let's try to answer next part now. For this part, we need to find current in the 12 ohms resistor. Means current through this resistor we need to find out. So how we can find out this one? First way is a very straightforward one. As we have found the EMF of this battery, means the voltage across this one, that was equal to 6 volts. That was equal to 6 volts. It means the same potential difference is across 12 ohms resistor. So we can simply say that 12 E2 has to be equal to 12 times I. 12 times I. So as we know, E2 is equal to 6 and this is equal to 12. So we can find value of I. So I in this case will be equal to 0.5 amps. So this is we can answer, but we can also, let's try to use Kirchhoff's second law as well. For Kirchhoff's second law, let's say we start from this point. If we start from this point and we cross from positive terminal to negative terminal, so positive to negative means voltage will drop, so we will say this is minus E2, and then we go this side, we go in direction opposite to the current. So it means this has to be plus 12I and this has to be equal to 0. So from here again we can find I, that will be equal to E2 divided by 12, and E2 is equal to 6 volts divided by 12 ohms, and I will be equal to 0.5 amps. So this is how we can find value of current passing through 12 ohm resistor. We need to find the current in the circuit, and question is also telling us choosing the best loop can simplify the problem. So this is very important technique. We always try to choose the best loop. So how we can define the best loop? So let me write down here for you what is the best loop. So the best loop, simply we can consider a loop with less number of unknowns. With less number of unknowns. So this is one condition we can set, and the second one we can say with few components. So this can be the second condition, with few components. So we no need to calculate a lot. So let's try to choose the best possible loop now. And this is what part A is asking us. Best loop. So let's say if I take this loop now, this is one loop. So in this loop, you can see I we need to find. So this is our unknown, but we also don't know what is value of I1 passing through 20 ohm resistor. So it is not a good choice to choose this one. So this is not good choice. Okay, so now let's go and choose another loop. Let's say if we take this loop now, let's say we start from here and go this way, and we consider this loop. So in this loop we need to find what is I, but we don't know the value of I1 through this 10 ohm resistor. So you can see we have two unknown. So again, this one is also not a good choice. So this is not good choice because two unknown. So we are looking for a loop. We just have one unknown. So we can quickly find value of current. So let's look at this loop now. So let's start from here and this loop. Okay, for this loop, we have less number of components. We have three components involved, two batteries, and the EMF is given to us, and we have resistor, its resistance is given, and this is our unknown what we need to find. So it's a very straightforward one. So we have one loop, one unknown, we can find quickly value of current. So here is part B. So part B is simply asking us to find value of current. So how we can find now? Simply we need to use KVL. We need to use KVL. So in KVL, we simply understand in any loop, delta V has to be 0. So if we take this loop, we start from here. As we go from negative to positive terminal, voltage has to be positive. So 5 volts. Now, next one, as we go in direction of current, voltage will drop, means minus. So we have I, and this is the resistance 10. Now, if we go from negative to positive, so we will gain voltage. So this is 5, and overall it has to be equal to 0. So now we can simplify this one. So we will get 10 on one side and 10I on other side. So it means I will be equal to 1.0 amps, or simply we can say 1 amps. 1 amp.